Alright, hello. I'm going to record a tutorial on how to use the volumetric Vesuvius labeling based off of Napari to inspect 3D ink volumes as well as validate and update labels. The first thing I'll note, which I'll write up in text a lot better, is some of the changes you want to make to the config file. You want to make sure you're using a good scroll name for which scroll you're on. I just use S1, S2, S3. It just changes how the folders are named and how the files are saved. Additionally, if you're going to be using the Napari for ink detection, I suggest making the main label layer name ink, because that means all the default key bindings will be for the ink label instead of the papyrus label. Additionally, you'll want to point to the ink labels R's. That's how the ink labels are presented, and that's how I'm loading them in. So make sure you set the ink prediction ZAR path. Ideally, you're also loading the raw data from a ZAR like I am. You can load the raw data from NRD cubes, but that makes some of the axes alignment a bit harder because the NRD cubes are ZYX, and that's the standard I'm using, but the ink predictions are not necessarily ZYX. If you're using a raw data and an ink predictions are, the code will be able to automatically align them from the ZYX values, but otherwise you'll have to provide the axis order down here. Just one other note is the ink threshold is the value that, given the prediction, below that it says not ink, and above that it says ink. Brunus's 3D ink predictions I believe, are pretty much already binary, but ML Ryan's ones are on a spectrum, so if you want to get a different threshold, you can set that value. Otherwise, most of this is the same as the volumetric labeling, but I'll leave a link to a document explaining the config better. So once you have the ink predictions and have raw data and load up, put those in and launch Napari, you'll be greeted with a scene somewhat similar to this. Here we have the ink labels, and if we run connected components, because right now they're all label 1, we can select the ink labels layer to run it upon, and once we do that, they'll all be assigned a different label value. One thing to note is if you choose a really large ROI, things will get slower because you're loading more data, but there's also the color map only goes up to 180 at the moment, so some of the labels might become invisible if you have a bunch of tiny small ones. Additionally, connected components filters out, I believe it might not be in that particular one, but there should be a connected components minimum size in your config file, and if any object is below that size, it gets filtered out or essentially deleted. So you can set that to different values. I found 300 works fairly well. Objects below that are usually not what you want. But then what you can do is once you have these floating ink predictions, you can select the ink labels layer, then the eyedropper tool, and click on a label to select it, or type the number in here, go up and down. And then what you can do is if you hit N while you are on the data, when you have the ink label selected and the label, and hit N, it'll align the data plane with that label. And then if you hit S, you can hide the labels, and A and D will allow you to slide the plane through the voxels and inspect what that machine learning signal is actually picking up. This can allow you to validate, like, is this prediction a valid prediction? Do I think this is what ink should look like? As you can see in this section, there's clearly some sort of crackle. This is on scroll 3. Is that crackle ink signal or not? We don't know. Crackle seems to align to ink fairly well on scroll 1, but there's definitely ink on the other scrolls that is clearly not letters, at least. And then if you might notice that there's other parts of ink floating nearby. So if we go here, we say, oh, okay, there's some crackle looking signal that isn't picked up by the ink prediction. So if you wanted to add to the label, you can come to the label annotator tool over here, make sure the ink labels layer is selected and the labels layer, and then if you activate that and use the paintbrush, this will allow you to draw on the plane. Unfortunately, with the larger size, it is fairly slow, but one thing I'll show you is if you have a label selected and then hit Shift N what this will do is it reloads the data, but with that label selected in the center of your cube, and it loads it in a smaller size. In particular, it loads it to the edit chunk size. I found 256 it works pretty smoothly on my computer. If you happen to have more powerful or less powerful computers, you can make the edit chunk size larger, bigger, smaller, and this sets the coordinate values with the label you had selected in the middle, so then you can clean up one particular part and save it and just have like, okay, this ZYX coordinate value lines up with that part. So say we wanted to add a label there, as we already have that there, and then maybe we'll select this label. Well, actually, let's run connected components first, because when it reloads it from the raw. So we'll go like this, get the paintbrush out, and start to connect this part, because it looks like whatever that signal is, it clearly exists here also. And then maybe, I'm sure you could do other parts, but what I'm trying to get at is you can connect two islands, and if you rerun connected components, it'll have that whole thing selected. And then yeah, and then you can, this should allow human in the loop iteration cycles of you looking at the prediction, identifying what it's actually predicting, saying, is this what I want it to be picking up? And then correcting the labels either by adding to it, or you can also use the eraser in 3D to erase parts that you don't think belong to it. And then from there you can hopefully get better labels to machine learning algorithms and go on in parts that are not segmented to 2D. This process might be faster in 2D, but you don't need to have the part you're inspecting segmented, so it might be a faster path for particularly the first letters prizes. An additional note is if you have the data layer selected, there's a plane thickness slider, and what this does is the higher value it is, the more voxels it's taking information on and displaying on the 2D surface. The rendering determines how that's shown. So this is maximum intensity projection. So in the neighborhood of 3.43 voxels, it's taking the highest maximum intensity. There's also minimum intensity, just straight up averaging, attenuated maximum intensity. There's additive, where it just adds them up so you get really bright. But with this, it's probably easy. It's definitely easier to see, to get a better picture of how the fibers are going and how the cracks and other features are presenting themselves in 3D. This might also allow you to start to label other features and see if you can get a picture out of them. And it's also just very addicting to slowly move through. I know you can use S to hide and show the labels the same as the volumetric Vesuvius labeling. And there's all the functionality from the volumetric Vesuvius labeling should also work with this, but it's less relevant. And once you think your label is good and ready to go, you can save it with H or this. Usually it takes a bit longer, but because there's not many voxels, it finished pretty much instantly because it saves asynchronously. And hopefully this allows a pathway for manual verification of 3D ink detection predictions, as well as improvements via addition and subtraction of the label, so we can start reading ink on the other scrolls where we do not have much segmented. All right.